So this afternoon I have a very light topic, unlike the other sessions where I talked about threading or unit testing or APIs or whatever. Today we're just going to talk a little bit about the standard libraries. With any worked with any programming language before, you know all of them have some sort of standard library, whether it's Python or Java, whatever. And the goal of that is that you don't have to write all your code from scratch when you want to do simple things as use an array, use a dictionary. Some cases, the standard libraries are more extensive. They allow you to work with dates, create HTTP requests, and so on. The cool part about iOS is that we don't have only one standard library, but we actually have three in total. One provided by Swift, which is the Swift standard library. One is called Foundation, which is primarily written in Objective-C and is fairly old, but we have an even older one called Core Foundation, which is mostly written in C. And the only reason I have to give this lecture is to basically make you aware that there are three different ones, and you might work with one of the three at any point in time. And I think it's more or less important that you understand what these three different ones are, what the differences are, and when you probably would use one or another. So we're going to talk about the three standard libraries. Then we're also going to talk about bridging, because luckily all of these are fairly intercompatible, which means you can work with Core Foundation and transfer that into something that is in the Swift standard library and back and forth. That makes it possible to work with really old code on iOS, which is very important for a lot of companies. And finally, the last part, I'm going to spend talking about a few specifics of the Swift standard library that are a little bit special and that are worth pointing out beyond the regular documentation. So here's basically a stack of the three standard libraries that we have. I mentioned them. We have right at the top the Swift standard library, which is very, very new. And it's also still very small. I have a separate slide for that, but it basically only has a few standard data structures. Anything that you want to do that actually involves building a full app that does, like, for example, HTTP requests, you will always use the Foundation framework. Because 80% of the features that you need in every app are still written in Objective-C and are part of that Foundation framework. And right at the bottom, we have the Core Foundation framework. The interesting part about that is that it's mostly open source. So once you're a super expert iOS developer, you can actually take a look at the code and see how the standard library that is like 30 years old was written. And a lot of the features in Foundation actually rely on that Core Foundation library. So if you want to see what a standard library looks like and look at the source code, you can take a look at that here. Core Foundation, for a short historical reference, if you watch the Steve Jobs movie, you know that Steve Jobs at some point in his career left Apple and went to a company called Next Step. And basically at Next Step, they built this Foundation framework. And that's why all of your libraries that you use that are part of the Foundation framework are prefixed with the letters NS for next step. NS strings or NS URL requests and so on. And even older is Core Foundation, which was written as a common ground for Cocoa, which is a framework we work with now, and something old called Carbon, which was a totally different, no longer existent framework for developing macOS apps. So that's just for a short history lesson. So let's talk about the Swift standard library. As I said, essentially only a few very basic types are provided. Dictionaries, strings, int, all such kind of stuff. One of the interesting features of the standard library are optionals. We're going to talk about them later. And that's also a cool part about Swift. I don't know if you're familiar enough with programming languages, but essentially there's always a difference between a feature that is provided by a compiler, which you would call a language feature, and a feature that is provided by a library, which is basically just some code written in the language that you're compiling with. In Swift, almost all features of the language are actually implemented in Swift themselves. So you can basically change a lot of the programming language and extend a lot of concepts of the programming language. So the concept of an optional, for example, that you should know from Swift is not only in part something the compiler knows about, but it's actually also a type in Swift that you can extend. We're going to talk about it more later. But as I said, the Swift standard library itself is not super useful yet. If you want to do date calculation, if you want to work with the file system, if you want to work with servers, you have to use Foundation. The interesting part about the Swift standard library, and we're also going to talk about that in a separate lecture, is that it consists mostly of value types, which are structs and enums. So that's a very much Swifty concept that we're going to talk about more. But the cool part is that the Swift standard library doesn't use a lot of classes, and that changes some of the functionality, but we'll discuss it separately. So the second framework you're going to work with is Foundation, and Foundation is basically the biggest framework that provides all of the cool features that you need for building your apps. It also has data structures, So you again have arrays and dictionaries. But when you work with Swift, you're going to use the Swift types and not the Objective-C ones. But they do exist. Then beyond that, it has date and time. For example, NSDate, NSCalendar. It has a URL loading system called NSURL session. We're going to have a separate lecture on that. It has the file access system, which is in NS File Manager. And it has a ton of more frameworks. Now, the foundation libraries, that's more a technical detail, but it's kind of interesting. As I said, we're going to cover that in a separate lecture. But all of them are implemented as classes. And there's also a thing that a lot of people that come from a Java background or other languages are not super familiar with in Objective-C. And that is the concept of immutable and mutable classes. So immutable classes are ones that can only get a value as soon as they are created, and they cannot be changed over time. And mutable ones are ones that you can change after they have been created. So in Objective-C, if you create an NS array, you have to provide all the elements that go in the array up front, and you can't add or remove any later, because it's an immutable class. If you want an array where you can remove and add items, then you have to create an instance of NS mutable array. In Swift, these concepts don't exist anymore in that form, but if you work with Objective-C, that's one of the things you might be confused about, so understand that there's a difference between the mutable classes and the immutable ones. And all mutable ones are basically have somewhere mutable in their name to mark that. So let's talk about bridging. As I said, we have 3 different standard libraries, and as you work with different APIs, you will see that each of these APIs uses a different library. So far, Swift library is not used by any frameworks that you use frequently. So all of them are either Foundation or Core Foundation. Core Foundation is for low-level stuff, typically, like custom drawing, custom rendering, some of the math libraries. But the cool part is all of these are what we call toll-free bridged. We're going to see an example on the next slide, and we're going to have a whole full lecture on the interoperability of these different frameworks. But essentially, it means you can take a Core Foundation array, which is called CF array, and you can assign it to a Swift array, and the compiler and the runtime will work together to basically convert that. What can it look like? Short example here for printing a string. It might help to open a slide on your computer. So this string here says this is a test, and it has 2 of the emoji characters that have an American and a German flag. And I have 3 different strings. The first one is a Swift string. I basically don't have any type here, so it just automatically gets stored as a Swift string. Then I have one that I store as an NS string, which is the Foundation type. And I have a third one which I store as a CF string, which is the Core Foundation type. And all of these I can basically use interchangeably, and I can assign any of these variables to each other. I can bridge all of these strings between the different types. One interesting difference between Swift strings and the Core Foundation and Foundation strings is that the Swift strings are really good at working with emojis. And you can see that when you look at the length of these strings. When you print the length of the string for the Swift string, you get 16 characters, which is actually the amount of characters that you have in that string. Whereas the Core Foundation and the Foundation string claim that a string has 23 characters. Does anyone know why? Or have an idea why? Josh? Yeah, basically. So things like emojis were basically, there was no space in the Unicode specification for these characters, so they're basically a combination of different other characters. To encode one emoji, you have to use, in this example here, 4 different characters. And because all of these old libraries are so old, they didn't know about that new encoding, so they basically give you the length of the amount of characters, even though the visual characters are less in that case. So Swift strings allow you to work with that. And I would say, together with date calculation, working with strings is one of the most complicated things in programming. So if you're interested, you can dive into the details of the Unicode specification. But yeah, that's kind of an interesting aside. In general, always work with Swift strings if possible, because they're the newest. So basically, appending to that a little bit, you have some weird things with Swift strings that you won't be used to because of the fact that they are able to basically represent Unicode strings correctly. And the one is that you cannot iterate and you cannot access any element of the string as it would be in an array. So you can't say I want the 10th character of the string, because the string doesn't really know what its 10th character is until it went through the entire string and resolved which 4 characters have to be mapped to which emoji and so on. That's why accessing any element in here, you basically have to iterate from the beginning to the end. It's like a linked list. That makes accessing characters really expensive. So if you work with an app that basically works with hundreds of thousands of strings, and you want to access any specific characters of them, then you should consider maybe just forbidding emojis and then working with the NS string or core foundation strings because they're much faster. Yeah, that's just a small aside. But you can still get the actual character count. So if you want to get all the Unicode characters in here, then you can say swiftstring.utf16string.count, and then you'll get the number 23. Okay. I also talked about optionals, and understanding optionals is really a fundamental part of understanding the Swift programming language. We're gonna, for those of you who didn't program in Swift for a while or not at all yet, we're gonna have a separate lecture introducing it. But the cool part about the Swift standard library is that optional, as I mentioned, is also part of the standard library. So if you want to know how an optional works, in Xcode you can click on the optional word, you can command click onto it, and you'll see the source code. And the cool part about an optional is that it's actually implemented as an enum. Who has used an enum in any programming language before? Some people. So enum is basically a specific type that can only have a subset of available values. So an integer can have any value between 1 and 4 billion, for example, whereas an enum can only have a specified set of values, and you have to specify which values are valid. A common type of describing things you could describe with an enum are, for example, the gender. You could say these are the potential genders that are available. And an optional is the same. It's also an enum, and it has two different cases that are possible. It can have nothing stored in it, or it can have something stored in it. And yeah, it's just a cool thing that is actually not some magic implemented by a compiler, but it actually took Swift and implemented the optional type that is very important in Swift itself. Also means you can switch over an optional the same as you can switch over any other enum value. But yeah, we'll get into that as part of the Swift lecture. Another cool part is if you worked with Swift before, then you maybe notice notation here at the bottom with the exclamation mark. So if you have an optional value, it means the value can be available or not. And before you use it, you have to, the compiler forces you to check if there's a value inside of the variable. If you don't want to check, if you want to be lazy, you can use an exclamation mark and say, hey, I just assume something is in here. Let me treat it as if it always has a value. And in case there is a value, it works. In case there's no value, your app crashes. And that thing is called an implicitly unwrapped optional. And typically, you use it by appending an exclamation mark to an optional. So in any other language, you might think that a compiler actually implements that and says, hey, if there's a variable name and then an exclamation mark, then I'm just going to try to unwrap the value. But in Swift, it's also implemented as part of a standard library. So instead of using the exclamation mark, you can also say, I want to create an implicitly unwrapped optional, and you can pass in the optional value. So all of the exclamation mark and question mark things that are implemented in Swift are implemented by the compiler, but they're just syntactic, what you call syntactic sugar for things that are actually implemented in the standard library. So you can basically change how an implicitly unwrapped optional behaves. You can change how the Swift language behaves because it's all implemented in Swift. Kind of exciting. Cool. Let's also talk about protocols. Another Swift language feature. And as I mentioned, the Swift standard library is very much different from the Objective-C one because it doesn't use any classes. The Swift standard library uses a lot of protocols and structs. And as I said, we're going to talk about that. But the cool part is you can extend the language. I'm going to enforce it over and over again, which allows you to build really cool concepts. So let's say you have a type in your app, and you want the user to be able to create something of that type by using a string. Then in Swift, you have something in the standard library called string literal convertible. They all have really good names. The string literal convertible allows you to take a string and create an object from it. So if I want, for example, a car class, and I want that car class to be able to be initialized with a string, and just a string, I don't have to create new car, then I can make the car a string literal convertible. I can implement that protocol. And if I do that, then someone who uses this class in code can just say let car and define that it is a car type, and then say equal Mercedes. And then this class here is responsible for taking the string and creating itself based on the string input. I think it's pretty cool. Don't know if someone else thinks it is. You can try it out, it's pretty fun. Okay, that's basically it. The most important part is don't be confused by 3 standard libraries. If things have a prefix with CF, then they're core foundation, which is the oldest standard library. If they have NS, then it's the foundation library. And if they don't have any prefix, but they're called things like string literal convertible, then they're Swift. Yeah?
What would be the use case for that?
For the last, the interesting use case is primarily making the code a little bit nicer in some cases. Like, I basically just want to show one example. Like, all of these extending the language examples are really typically used when you program in Swift for a year, and you look at your code and think, hey, there's a better way of doing that because I know I can also initialize it with a string instead of creating a class and then setting a string and then setting another string. There's no, like, any other way of doing it is always valid. It's like a 5% better thing. I think it's more a way of demonstrating that you can do it less than that you would actually need it. Yeah. But there's some, for things like optional, there are some more use cases. But yeah, we're going to have a separate lecture on that. Cool. Finished. Thanks.